Hello and welcome to this recorded DI about the Ohm's law. Now, the Ohm's law is the mathematical relationship among three variables: current, which we represent as big or capital I, resistance or big R here, and voltage or letter V. Now, the principle is named after the German scientist George Simon Ohm. Now, the units of measurements will be as follows. For V, the unit of measurement would be capital V, that means volts. Current, represented by I, the unit of measurement would be A or ampere or AMP. And R here is resistance. The unit of measurement would be this omega, this Greek letter omega, and it's called ohm. Now, you're familiar with the triangle method for solving any three variable in a given formula. And it's very simple. Again, as a reminder or as a refresher, maybe. So if you are interested in V, for instance, or the voltage, you just cover it up with your hand. And if you see two variables side by side, that means to multiply. That's why I have here the formula for V as V is equal to I multiplied by R. Now, if you're looking for I, again, cover up letter I there, and you're left with V in the numerator and R in the denominator. So that is now V divided by R. So there you go. There you go. And if you're interested in getting the R, cover again R, you're left with a V in the numerator and I in the denominator, which gives you this formula. R is equal to V divided by I. So let's try and just do it using our GRS strategy. You have a similar set of problems that you will do in your Google assignment. Now, this DI is simply for demo purposes, and the problems are available in your booklet on electricity. So let's try and do this together. Now, let's go over page 18 of your booklet, and it would say here there we have some practice problems that we can do together. So the first one here, now let me make this bigger. See what I have here. Okay, so on the booklet it says here an alarm clock draws 0.5 ampere of current when connected to a 120 volt circuit. Calculate its resistance. So how do we solve this? So using the GRS strategy, okay, an alarm clock, you exactly know what that is, right? So, but I do have here some sort of a visual maybe, and probably the uses still of alarm clock even in this millennial age. So usually it says here an alarm clock is a practical alarm clock which turns your Chrome into beautiful digital clock. So maybe you can do that also if you have a Chromebook at home. So you can set the alarm there. But in any case, so an alarm clock is given. What else? Notice that we will be dealing with these three variables here. So in this problem, the take a good note at what you have in the problem. Take good note of the numbers that you see there. So you can see the, let me just try and call on the focus here. The 0.5A. What is A again? Yes, you're correct. It's a unit of current because A or ampere is what we have here, right? As the unit of measurement for current. So let us write it down. So 0.5. So we have 0.5 ampere. So that would be I. So let's just type the value here. I equals 0.5 A. We now have one value there. What else? In the same problem, when connected to 120 volts, so volt, what is that? A unit of voltage. So this is also what is given here. V equals what again? It's 120 volts. So what else we have here? So two are given, so required. So calculate its resistance. So required would be letter R. Okay. So what's the unit of R? Can you remember? So R, it says here, should be in ohm. Let me just copy the omega Greek letter here. Maybe just make this bigger also to just conform to the rest. Okay, so we now have that unit for resistance. So you're looking for resistance. So under solution, you need to have the formula now. So R would be V, so cover R, right? And you come up with V divided by I. So let me just copy that formula, scroll down. There you go. I intentionally just made it bigger so that it's bigger on your end. So you don't have that working formula. Once you have the formula, easy. You can just substitute the values now that you see. So R now becomes V. V is what? So don't forget the unit of measurement there. It should be in volts. You can have it in small v or capital V. So here, now have 120 V divided by what? I. I is 0.5 A. So very simple. So R now becomes 120 divided by 0.5. Can you do mental math? So I have here an online calculator, right? You can also use your cell phones maybe or whatever calculator that you may have in class. So let's go back to what we have here. So 120 divided by 0.5. Get your calculators out. Try and see if you are getting the same answers. So 120 divided by 0.5, 240. So 240 would be the answer. 240 is a unit. Of course, it's in ohm. Done. That's so bad, right? So not so difficult. So when you get to the second problem, let's see what we have here. And some of the words there might not be in vogue now, like the idea of a subwoofer. What in the world is that, right? So I have here a link, a hyperlink. Let's see. The second problem is about the subwoofer. Okay, so it is what, some sort of a loudspeaker that handles the lower frequencies or bass. So that's what it is, right? So in the second problem, it says here, a subwoofer needs a household voltage of 110 volts. So 110 volts, that's part of the given. So voltage is given here as 110. It must be a North American electrical outlet, right? Or are we 220? Hmm, we should all know that, right? But in this problem, it's voltage is 110 volts. Okay, so maybe it's nice to just have a small v for the unit of measurement, right? And capital V to represent voltage. So what else is given in the problem? So 110 volts to push a current of 5.5 A. A again is what? You're correct. That's current, right? And current is represented by capital I equals. So we have here 5.5 A ampere. And of course, the remaining variable is S. So what is the resistance? So again, resistance is S. So resistance again in omega or ohm. So this now the advantage sometimes of doing it online. Your solution you can cut and paste, right? So the same formula here. R is V over I, and then substitute the values that you have in the problem. So this is now R equals what? What is voltage? It is 110 volts divided by, what's our I here? I is 5.5 A. And then get your calculators out, or if you have an online calculator, then easy, right? So where's my online calculator here? 110 divided by zero point 0.5, 110 divided by 0.5, you have 220. Okay, 220 as the answer here. 220, what's the unit? Again, we have it in ohms, or the omega, the Greek letter omega. Okay, that's it, right? So in number 3, what do you have here? Again, on resistance, right? So let's have something different. What is the amount of current? Maybe we'll just jump into number 4 here so that it would be a different spin on problem solving. So number 4, for instance, although in number 3, we have something about a Walkman. You might wonder what that is. Maybe it's not in vogue anymore, maybe during our times, or during the times of your parents or grandparents. So it's a cassette recorder, right? So gone are those days, right? But you can just see how ancient the set of problems that we have here, but still the principle is the same, right? So it is immortal in a sense, right? So principles are principles. They don't go outdated. So let's proceed with number 4 problem here. So in number 4, so let's just use number 4 here. Let's see what we have here. So I intentionally missed out number 4. Maybe in class we can just do all the problems all together, right? But hopefully our remote learners can really just be helped out with this recorded DI. So number 4, so let's see what we have here. Number 4, it says here, if a toaster produces 12 ohms, so that would be what? R is 12 ohms. So R is 12 ohms, right? So then let me just copy the unit for ohms here. And you can do the same, right? And so you have that 12 ohms and what else? So it says here in a 120 volts. So V is 120. So V, and I'm pretty sure I is now asked. But let's see how this is worded out in the problem. So it says here, what is the amount of current in the circuit? So amount of current, of course, would be the letter I. Okay? So what's a unit of I or current? We usually use letter A or ampere. So I, how do I get the formula? How do I get the formula from the triangle? So it's again just putting your hand over the I there so that you now have V divided by R. So I is as. So let me just copy this formula from this from the top of the worksheet or from the top of the Google slide. So here, so you now have this formula here. So let me just make this bigger so that you can see it. Okay. So there you go. I divide by R. So here, I now is what? V is 120 divided by what? R, which is 120 or 12 ohms there. So what is I? Do I need a calculator here? Or you can do mental math? I'm sure you can do mental math, right? But if you're not sure, you can always say 12. Where's my calculator here? So let's now have that 120 divided by 12 is of course what? 10. I know you know that. So 10. So again, let's go here. So you have 10 what? So unit ampere. Okay, there you go. So I hope you find this informative at least. But of course, nothing beats doing it in class live with the teacher. Okay, that's it for now, people. Ciao.